Well, next up, we have Marino from Kong. Is Marino on the line with us? There you are. How are you doing? Oh, you're doing great, but I can't hear you.
I had the double mute going on yet
The
again.
double mute.
It always
The
happens to me.
second mute
Fen,
that
how are
always
you
gets
doing?
you. I'm doing great. It's good to see you.
It's great to see you too. I love the hair. It looks
Thank you.
fantastic.
Thank you.
All
You
right.
too. You too. Hair's looking great. Now that both of our hairs have been complimented, yeah, why don't you jump right in and we'll take it from there. So we're not keeping you too long.
Sounds good. All right. Let's go. Yeah, there we go. All right. Welcome, everyone. And I hope y'all are having a great day. I'm here to talk about some of the practices that we're going to be following and we're going to be seeing, especially when it comes to leveraging uh, AI, artificial intelligence, general intelligence, and generative AI in various forms. And part of the reason for this talk is because everything comes down to it being an API. But as we start to see developers consuming more and more of these different APIs out there, it creates a little element of shadow AI, and we want to be able to embody the platform engineering practices when it comes to leveraging AI technologies altogether. So I'll start off with who I am. My name is Marino Wijay. I am a solutions architect at Kong. I work with a variety of end users to just get them onboarded into working with API gateway technology, networking, service meshes, and just help them with connectivity challenges. So it's kind of fun doing that. But I somehow along the way managed to stumble upon a lot of the AI work that's been going on here at Kong. And a lot of it has to do with the fact that because everything is an API, we can treat it as such. And we can use a lot of the same practices and principles we've been using forever, the foundational stuff, to effectively manage AI the same way we would manage any of our other applications and services. But the idea here is really about how to consume it and how to implement it into our pipelines and our life cycle. So I have a few things that I'm going to cover today. The first is just a few things around large language models and the basics around, as well as we'll dig into ways we can go about augmenting and optimizing the consumption of generative AI. And we're talking about like a lot of these SDKs that are available to us that we can consume and write through with various programming languages. Then I'm going to get into some core functions, some that are pretty important that help optimize the overall experience of an application when it uses a particular large language model. And then we'll get into a demo. And I'm going to be quick because the reality is like I know like slides are fun, but I think the demo stuff is even more fun. So let's get going. Large language models. They are advanced AI systems that have large data sets that they learn from. Effectively, what goes on is you're training this machine about a variety of bits of information that might be related or unrelated or across a large set of domains. And the point is to get them to become very intelligent so that they can respond to you in almost a human-like nature. But what we've seen so far in the industry is a lot around being able to use chat engines. So a chatbot, which actually is very smart and can give us some really good details. It also gives us the ability to do some quick calculations because who the hell wants to sit there and like run through the quadratic formula or develop functions to calculate a variety of different values, which you could do. You could actually program, and there are probably plenty of available functions out there, but you could also call an LLM to do that for you. And sometimes you just want sample code. So I'll show you a little bit about how I'm consuming a lot of these LLMs and one of the ways we streamline this, especially in enterprise operations. Now, there's a few ways that you could normally get started. Everyone's probably very familiar with OpenAI's chat function, and you effectively go in there and you ask it a question and you got an answer. And then there are others too, like Gemini, Copilot. A lot of the other models are available through SDKs that you can program, and you could just call out and build your own little multi-LLM chatbot if you wanted to. But we start to see a lot of these used in a variety of different domains. And in the enterprise, we start to see how we build with them. Like we begin to realize that developers want to be able to build with them. And so they'll go out to OpenAI or Mistral's documentation and pick up the SDK information, pick up a few examples, and then start consuming those providers pretty quickly. But what ends up happening is now you have several sets of providers that are doing different things or answering different questions or providing different responses to different kinds of queries that you send out there. But there's no way to streamline this. You have a loss of visibility and monitoring. You don't know how much you're spending as you would expect. You don't know the latency or the round trip time of how your applications are going out there to get their queries responded to, or maybe some function calculated. Like you're going into your code and saying, calculate this or do this or iterate through this. And some LLM will do that for you instead of you having to write out the entire logic. But we have to feed this ideally through a system to be able to better optimize the usage of these models. So there are different options out there, different providers. I work for Kong, so I'm going to talk about the Kong AI Gateway a little bit. I just want to focus in on the ideology behind it. So let's focus on a little Python application, which I'll show you something very similar in VS Code shortly. And this is just the OpenAI client where we're passing in a question either at runtime, or we could even specify it as a variable. And then OpenAI will come back with a response, and we can even specify the model. Now, if we wanted to be a little bit more flexible and not have to lean on developers or platform teams to have to know the message format or the structure that we have to send to an LLM provider, then we could feed everything through the Kong AI Gateway or through an AI gateway. Now, the structure between Mistral or OpenAI or let's say Gemini or even like Amazon's Titan, the structure in which you pass in data will vary a little bit. And so one of the things we want to be able to do is help you with that. You send us a prompt or you send a query through the AI gateway, and as long as you're specifying your model and what you're attempting to do, whether it's a chat or a full-on completion, then what ends up happening is we'll pick out the right model and route you accordingly to the appropriate model. But there are other things we can do too. What if you don't want to go to a SaaS-based provider? Maybe you want something local, like you're using an open source-based LLM like Olama. And if you're doing so, then chances are you're cutting down on unnecessary bandwidth and unnecessary cost consumption. Now, there's a number of ways we can optimize the usage of these APIs. We just need an API endpoint, and we define how to get to it, and the kinds of policies we'll apply to it at a gateway level. So that gateway address that I showed you, which I'll show you again in VS Code, will be a little bit more specific and route all those requests or have those requests centralized to this gateway. The gateway will then determine, hey, where am I going to send it off to? So the things to consider is maybe you don't want to plug in every single SDK client into your code. So now you're just using a single API endpoint, which is the Kong AI Gateway. And then you as an operator decide, or the platform team decides, well, we want to prevent certain kinds of prompts from being asked. Like we obviously don't want to send out any sort of inappropriate or malicious or harmful prompts. We don't want to send out prompts that might return some malicious executable code that might be run in the environment. So we can use some sort of prompt guard. Maybe our developers haven't quite provided enough context to what we are trying to define or what they're trying to define as a function. So we can decorate those prompts a little bit to be a little bit more contextual. Think like a software engineer that knows Python and has seen the version 2 versus version 3 and understands the differences. These kinds of bits and pieces of context are pretty important. What we can also do is we can also take in some of those responses that we get back from the LLMs and transform them. We can modify them appropriately so that we can return them in a data format that is understandable by our application. And we can do the same thing when we're sending out a request. We can transform the request and shape it accordingly so that on the receiving end, it is much more defined or clearly defined, or it matches the syntactical format that that provider is looking for. And then there are other things that we can do, like we can rate limit too. For example, maybe we want to rate limit how many API requests go out to any of these providers. And after a certain point, we start shifting everyone to the local models. Or maybe the local models are also rate limited too, because we don't have enough available infrastructure to support the many requests that are coming in. And then we could also provide our developers some templates that they can use so that they don't have to sit there and construct the kinds of prompt templates or the prompts that they need to for their applications to return data. And then there are a few advanced functions as well. So there's the advanced proxy, which if we're thinking about routing and effectively routing based off of a variety of criteria, latency, distance, we're thinking about the amount of cost we have to spend for that response or that query that we send out, the tokenization aspect of it. All of these things can be taken into account, and then we can make decisions about how we route to those models. So aside from that, we take that additional advanced capability and pair that with the ability to cache. So if I can cache my responses, especially based off of a similarity index, then I can proceed to return cache responses. I don't have to go back to the provider and have it construct a new response for me. I can also be a little bit more semantic about my prompts as well, so that I could tell the provider, don't allow us to ask certain styles of questions based off of certain criteria. So let's go ahead and dig into some of these so we can get right into the demo. All right, semantic routing. It's exactly like I said. It's like load balancing to different LLMs. Maybe we have highly available local LLMs that we're routing to, and then if for whatever reason they become extremely, overutilized, well, let's go call out to a SaaS-based model. Or the other way around, maybe we send specific calls out to a SaaS provider, and then most of our more common queries or common questions go to our local models. So we can intelligently route based off of a lot of different interesting information. We could classify user bases as well, so that certain classes use a local model versus other styles of users maybe use the SaaS-based model. Maybe certain applications, production-based applications, are using a model to pass in telemetry data back to us, back into our monitoring systems. So semantic routing is all based off of decisions, but we're actually having to provide context to that particular provider. So a sales team might need quick answers for product info because they're quickly answering a particular end user, while an engineering team, on the other hand, might need unit tests developed or a variety of other tests developed to validate whether or not their code works. And then, as I mentioned, it's all about availability as well. Maybe you're upgrading your local LLMs and temporarily you're sending every one of your requests out to the cloud. And so this is just a bit of a way to visualize this, and we could see where traffic is being routed to. So semantic prompt guard really helps us in different ways, where rather than blocking specific queries or static definitions of queries, we're blocking pattern types. So maybe we code a certain way, or we use a certain framework or language within our environment. I need some water because I'm running out of juice here. So let's just say we don't want to program in Go, but we want everyone to program in Python, or Java. And so what we can do is provide a prompt guard or a semantic prompt guard to effectively just not allow certain types of queries through, and it won't return a response. It'll just say this has been denied, or we could modify the response as required. But this is a little bit more contextual because we want to give the system a lot more information about how to return information back to us, especially if we don't want to program in certain languages or we don't want to instill certain patterns or building patterns. So we could actually just say, let's block C patterns or anything that ends in a .c, and that way we can just program a little bit faster or a little bit more aligned with some of our governance model or even our our policies and procedures within our organization. Now, semantic caching is an interesting one, and there's been a lot of work that has been done across the industry to optimize the way we consume large language models, primarily because every time we make a call out to a model, someone else halfway across the world has probably made the same call. Like, if you think about it, how many people are asking OpenAI, what is Java? Or how do you run Hello World in Java? And it's probably returning a variety of different responses. And it's probably even cached those responses too, because it knows, hey, a lot of people are going to ask about this. They're probably getting into programming. But on the user side, like if you're an enterprise, if you have 500 users asking that same query, it'd be more ideal if you can cache it. So the way caching works is you send out a query and something has to intercept that query and store that query somewhere. And at the same time, well, the query is going to be forwarded on to the model. And once it arrives at the model, we get a response. The same interceptor is going to capture that response, intercept and capture that response, and place it in some sort of cache. So now we have like this key value pair for a query to a response. And now someone else comes along and says, hey, I'm going to ask a query, something similar, and we're going to see if we get a similar response. And in actuality, if and this is tuning actually in how you configure all of this, if there is a similarity, well, guess what? You're going to get a cached response. And that cuts back on latency. That cuts back on token usage in a lot of different scenarios too, especially if you have like 10 users asking the same Kubernetes questions over and over again. What is a Kubernetes service? How do you implement a Kubernetes service? A lot of these have similar responses, so we can cache them. If you think like a MAC address for a second, like if you're in the network engineering world, a MAC address learns about MAC addresses and then we'll cache them so that the endpoints don't have to know about them all the time. They just query the CAM table, and then that table gets flushed out, and then it gets repopulated. That's effectively what goes on with what we use as a vector DB to cache a lot of these responses. There is an embedding model, and each provider has its own embedding model, and we cache specific types of embeddings, and then that gets stored in a database. Then we can go about and search it and then return the response as appropriate. And we call that a cache hit. And if there isn't a cache hit, if there isn't a similarity, well, what we end up doing is we just go right to the model and get a new response. So there's a lot of benefits and considerations to caching and semantic caching. And I'll leave this up here because I want to get to the demo, and y'all can take screenshots and review this offline. And then here are some pros and cons to take into account when you're building with LLMs and you want to implement caching, and maybe you're using something of a vector DB that might be Redis of some sorts. Now, I want to move on to the demo. The demo is like the most critical part here. So let's go ahead and do that. And what I've got here is not the one I wanted to show you first, and that's okay. You know what? I'm flexible. I'm adaptable. All right. So I've got a little Python application here, and I've also got another one on to the right here. If I didn't have this base URL, right, if I commented that out, what would end up happening is, and I ran this program, it would actually, well, you know what? I don't even need this. Let's use this one. This one's a much better example. I'm going to close this one. We're not going to save it. I don't need to save it. Okay, if I comment this out, what ends up happening is I'm actually making a direct call out to OpenAI. So OpenAI is going to take whatever input I placed in, and it's going to return the data. So what I'm going to do is, well, I'm not going to do it without OpenAI. I'm actually going to show you how I'm going to feed this data into my cloud gateway. And, sure, you can go ahead and try and do this, but guess what? It's not going to work for you because you don't have the key. You need the API key to be able to get in. But hey, that's actually a cloud gateway. We deploy this cloud gateway in Connect. Now, it's a SaaS platform, and one of the things to consider is a SaaS platform saves you the trouble of having to build out a bunch of control planes. Like it's just saving you that hassle. So you can go ahead and deploy your data planes. This entity, this endpoint is a gateway. It's an API gateway that has all of that AI gateway functionality enabled. The AI proxy, the semantic caching, some of the other functions as well. Now I've got this little script here because I'm like a little lazy. I don't want to type all the time. That's actually just going to go ahead and ask a bunch of questions. And in fact, it's basically just running this application against that question. So it just processes the input, and then it's going to send that input out to OpenAI, and then I should get responses. And we're seeing how long it takes, right? It's going through the gateway or the AI gateway, and it's taking roughly about 4 to 7 seconds per response. And after a while, you're going to notice something. Oh, here's one right now. I'm not going to go jump to the other ones, but there was a question that was asked. How does Kubernetes handle storage with persistent volumes? And it gave us a response from cache. And if you notice, that response only took 1 second. Like, look, if you went and asked Kubernetes or asked OpenAI, it wouldn't be able to construct all of this text back to us within a second. It takes some time to get all of that text. But what we ended up doing was we cached this response because it was asked like somewhere up here. We can go and find it. Maybe there is a response. Yeah, there we go. How does Kubernetes handle storage with persistent volumes? So we asked a similar question before, and because of that, we were able to get a response from cache. Now, this is important, right? 7 seconds versus 1 second. That's a huge difference. The latency we're actually seeing here is between my client that I'm running right now and the common gateway and the database that the gateway is attached to. The database is actually not living on the gateway. Right now I'm using Redis as a service, and that's fine too. Like, you could use any database as a service, but the idea is we're trying to reduce the latency. Now, what if I'm a developer and I wanted to test this from the lens of a developer and test out my APIs? So I've got this other tool here called Insomnia. Insomnia is a developer tool that allows me to just, form different curl requests to be able to sample what my API can do and how it can respond. And, if you're trying to model and mock your APIs and maybe even build infrastructure from an API standpoint, maybe using the OpenAPI spec, this is a great tool to come in and do it. In my case, I'm just making several calls out to OpenAI, asking it different things. But I want to show you some of the important data that come in, right? So let's go take a look at this. I have a body, and I'm calling out GPT-4 and telling GPT-4 to give me a hello world code in Python. I'm going to go ahead and send out that request. And it took about 2.22 seconds to get out a response, and it gave me a simple print statement for hello world. Easy enough. And then I've got another request out here, and I'm going to send out a request. And it's going to take a little bit longer because it's going to give me a very verbose response, right? It's giving me tokens that were consumed based off of the prompt and how long it took to give me an answer. And that's my response. Now, I have another Python request here as well. And let's go look at this one. Give me a hello world code in Python. And this other one here is, could you provide me with a sample Python app for hello world? I promise you this is not any magic or anything like that. What's actually going on here and what you're going to see is that because the response is cached, I get the response pretty quickly. So how did I know that this was cached? Well, let's go look at that first one. That took about 2.2 seconds. This one took about 1.52 seconds. So maybe about a 0.7 second difference. And this is probably latency between my Insomnia client and the gateway, and that's totally fine. But notice this. The X cache status was hit, meaning I went to cache. I went to cache because of the similarity index. I noticed that there was a similarity in the question that I was asking. So rather than going to the model, I'm just going to give you my cache response. And then I have another request here, which it'll probably take a little bit of time. But because it's so different, notice that the headers here are wildly different. And if you also notice, my cache status is miss. If I go to my first Python app, my cache status is also missed as well. So we're effectively helping optimize the way you develop your applications. Look, you're not going to ask OpenAI to give you, or whatever model you choose to give you, hello world code in Python. There are different, like that answer readily exists, but you'll be asking it to do other things too, like, return a function that adds two variables or something like that. And you know what? Let's do that for fun. Return a Python function that adds two variables together. And this is a completely different query. Let's look at what the answer is. It says define add two numbers, and then that's my code. So I could test and see different ways I can get responses back. If it's not what I want it to be, I can, decorate it, mess around with some of the plugins. But if you're also like messing around with Insomnia, you can actually define variables. I actually had to do this right before the demo because I didn't want you all to see what that key was, and you kind of highlighted it now. I have to go destroy my OpenAI key. Oops. But you can actually create variables here that just simplify your building process. So you don't have to go back in and recall every single one of those endpoints and whatnot. Now, let's go back to the slides. So there are a lot of different ways you can enhance your LLM consumption, and I just showed you one of the quickest ways to do so. You can get into using an AI gateway, and you can enable a semantic caching, and you can start caching your queries, provided that you're feeding it through the gateway. But there are other capabilities that you probably want to take advantage of too, like the ability to load balance and provide high availability to different kinds of models, and to be able to classify different users and tie them to the different models that they can consume, to being able to prevent certain types of prompts from getting out, even decorating your prompts to make them a lot more contextual and cleaner and whatnot. Now, look, I could sit here and go on for hours and hours about how this all works, but I actually invite you to go test this out. And this is a little bit of a visual that you could take a look for yourself, screenshot it. This might give you some ideas of how you can maybe consume some of these models in your own environment as well. But the best way to get started is, maybe get that little curl and bash script. And then, if you want to try the SaaS-based version, go head over to Connect. I would open it up to QA, but I really want to bring folks back on track. I want to bring the Equinix team back on schedule here. So, having said that, I want to thank you all for the time. And Fen, thank you so much for having me. I really
Yeah.
appreciate you giving me the slot. It's always fun to have conversations with the entire Equinix team and you just talk about cool things.
Well, thank you. And thanks for being here. I think this was a great insert into InfraCode, which is like not always something we think of as infrastructure, but like, yeah, all the tools we provide for whoever our audience is, whether it's developers, part of our org, or externally, like there's plumbing here about the infrastructure. And yeah, I think it's really cool thinking about the terms of shadow AI and everything like that too. Very similar to like shadow tech of people are going to use the tools they want to use, and better to be like, okay, here is a safe way to consume AI rather than just saying no, and then they're going to do it anyway behind your back. Right. Like, so I
Right.
thought it was really neat for both the security and consistency. Like all of that is very cool. So thanks for
Awesome.
sharing.
Thank you so much.